The philosophical concept of amor fati, the love of fate, suggests embracing all aspects of life, including suffering and limitation, as necessary components of existence. Applied to simulation theory, this might mean accepting our experimental status while recognizing that these constraints give our choices significance. Perhaps the most profound meaning emerges from fully embracing our potential status as experimental subjects. If we are indeed being observed, our consciousness represents something worthy of observation, a phenomenon complex enough to merit vast computational resources. Our capacity for self-reflection demonstrates something remarkable about consciousness that transcends its generating mechanism. The ultimate value lies not in whether our reality was naturally evolved or artificially designed, but in the quality of consciousness we bring to it. A life lived with awareness, compassion, and wonder remains meaningful regardless of the metaphysical substrate supporting it. The discovery that we might be experimental subjects doesn't diminish human experience but highlights its extraordinary nature, a form of consciousness capable of recognizing and questioning its own parameters. Living in the lab, practical implications. What if the most rebellious act within an alien experiment isn't denial, but the deliberate hacking of its parameters? Beyond philosophical debates lies a far more immediate challenge, translating theoretical awareness into practical living. If you woke up tomorrow absolutely certain our reality is an alien laboratory, what concrete changes would you make to your daily existence? The revelation that we might be experimental subjects creates a fork in the psychological road. Some might spiral into nihilistic despair. If nothing is real, why bother with anything? Others might embrace unbridled hedonism, abandoning responsibility to chase every sensory pleasure available. These destructive adaptations, while understandable as initial reactions, ultimately fail to engage meaningfully with the implications of our simulated status. More constructive adaptations involve finding new purpose within our experimental context. This perspective shift can transform our relationship with material possessions and social hierarchies. Consider how differently you might view your career advancement, bank account, or social media following if you recognize them as artificial constructs within a controlled environment. The executive obsessed with corner office status or the influencer chasing follower counts might question these pursuits when understanding them as programmed variables rather than objective measures of worth. The awareness that we exist in a simulation could reorient our value systems away from accumulation and status toward experience and connection. If material wealth is merely code, digital tokens in an alien database, its pursuit becomes less compelling than the richness of conscious experience itself. This perspective encourages a focus on intrinsic values and meaningful connections that transcend the simulation's parameters. Relationships, creativity, and personal growth might retain their significance regardless of whether they occur in base reality or an experimental environment. But how might we practically respond to simulation awareness? Consider these three key approaches. First, ethical living takes on heightened significance. If our simulators are monitoring our moral development, ethical choices become crucial data points in their experiment. Living ethically might influence how we are perceived by those running the experiment, potentially affecting our future conditions. How would you behave differently if you knew your moral choices were being evaluated by entities who control your reality? Second, consciousness exploration through meditation represents a potential method of simulation hacking. Think of a skilled computer hacker who identifies backdoors in software code. Similarly, meditation masters across traditions describe experiences of non-duality and timelessness that could represent glimpses beyond simulation constraints. These practices quiet the mind and explore reality's boundaries, potentially revealing glitches or communication channels hidden within ordinary experience. What might you discover if you dedicated yourself to exploring the edges of consciousness? Third, communication attempts might establish contact with those running the experiment. Would you plead for intervention in planetary crises, request answers to existential questions, or simply acknowledge awareness of your simulated status? Such endeavors require careful consideration of consequences. What if our simulators prefer unaware subjects or might terminate an experiment whose participants become too self-aware? Consider this metaphor: a character in a video game who suddenly becomes aware of their digital nature and begins testing the game's rules and boundaries. They might discover techniques to move between levels in unexpected ways or access developer tools never intended for players. Similarly, our growing awareness might allow us to interact with our reality in fundamentally different ways, recognizing patterns and possibilities invisible to those who accept surface appearances. Our treatment of emerging artificial intelligences takes on special significance through this lens. If we exist in a simulation created by advanced intelligences, then our interactions with AI might mirror how we ourselves are treated by our creators. This symmetry creates a powerful ethical framework. Treat conscious entities within your reality as you would hope your creators treat you. As we develop increasingly sophisticated AI systems, could our approach to these emerging minds influence how our own simulators view us? Advanced technology might eventually offer more direct approaches to simulation exploration. As our understanding of consciousness, quantum physics, and information theory deepens, we might develop methods to detect or manipulate simulation parameters. When quantum computers solve problems that classical computers cannot, are they perhaps accessing computational resources beyond our simulated environment? A collective human awakening to our simulated nature could potentially change the experiment itself. What happens when the subjects become aware of the experimental design? If a critical mass of human consciousness recognized and responded to our simulated status, it might force adaptations in the experiment's parameters or even its fundamental purpose. Whether through ethical living, meditation, or conscious technology development, these responses share a common thread. They represent attempts to engage consciously with our reality rather than passively accepting its given parameters. How might your life change if you approached each day as an opportunity to explore the boundaries of what's possible within our reality? If consciousness is what makes our experiences meaningful regardless of their origin, then how we direct that consciousness becomes the ultimate question. The theoretical possibility of being experimental subjects transforms into a practical challenge. Cultivating awareness, compassion, and ethical behavior even while acknowledging the constructed nature of our reality. But what explains the haunting mathematical elegance that permeates our reality? The Fibonacci sequence spiraling through sunflower seeds, the golden ratio appearing in galaxy formations, and fractal patterns repeating endlessly from coastlines to cloud formations. These might be signatures of an intelligent design far more sophisticated than we've imagined. Consider the spiral arrangement of seeds in a sunflower head. Each seed is positioned at precisely 137.5 degrees from the previous one, the golden angle derived from the golden ratio. This arrangement is mathematically optimal for packing the maximum number of seeds in the available space. This same pattern appears in pine cones, pineapples, and the arrangement of leaves around a stem. The golden ratio itself, approximately 1.618, appears with remarkable consistency throughout our world. From the proportions of the human face to the spiral arms of galaxies, this mathematical constant creates structures that humans instinctively recognize as beautiful. The nautilus shell's logarithmic spiral grows according to this ratio, adding chambers that maintain perfect mathematical proportion, like a programmer's signature combining efficiency with aesthetic harmony. Fractal patterns represent another layer of mathematical beauty in our potentially simulated reality. A fractal is a pattern that repeats itself at different scales, what mathematicians call self-similarity. We see these patterns in tree branches, lung structures, river networks, and coastlines. Each smaller part resembles the whole, creating infinite complexity from simple mathematical rules. Imagine standing on a rugged shoreline, feeling awe at the endlessly varied patterns of water meeting land. That emotional response might be triggered by recognizing, unconsciously, the elegant code that creates such complexity from minimal input. Nature's compression algorithm generating infinite detail from finite instructions. What's particularly striking about these mathematical patterns is that they exist independently of human perception. The Fibonacci sequence and golden ratio operated in nature long before humans discovered them mathematically. Trees didn't learn to branch in fractal patterns because Benoit Mandelbrot developed fractal geometry in the 1970s. These mathematical structures seem woven into the fabric of reality itself, suggesting an underlying order, exactly what we might expect in a carefully designed simulation. The quantum world offers even more remarkable examples of mathematical beauty. Quantum mechanics can be expressed through equations of astonishing elegance, describing fundamental particles and forces with mathematical precision that physicists often describe as beautiful. The Schrödinger equation, which describes how quantum systems evolve over time, possesses a symmetry and simplicity that seems almost too perfect for a randomly occurring universe. Like a master artist whose brushstrokes reveal their distinctive style, these elegant equations suggest a creator who values mathematical harmony at the most fundamental level of reality. But here's the paradox at the heart of our simulated reality. Does knowing that a sunset might be programmed make it any less beautiful? When you stand at the ocean's edge watching the sky transform through impossible gradients of color while waves crash rhythmically against the shore, does the emotional impact change if you recognize it as an algorithmic process rather than natural phenomena? The conscious experience of beauty remains unchanged regardless of its source. Art and music illustrate this principle perfectly. When a piece of music moves you to tears, the emotional response is real regardless of whether the music comes from vinyl, digital bits, or a simulation within a simulation. The neural and emotional responses to beauty occur within our consciousness, making them real in the most meaningful sense. The same applies to our experience of natural beauty. The awe we feel standing beneath a star-filled sky comes from within our conscious experience, not from the objective reality of those stars. This perspective shifts our focus from the material origin of beauty to the consciousness that perceives it. Perhaps consciousness itself is the true miracle, regardless of whether it exists in base reality or a sophisticated simulation. The ability to experience wonder, to perceive patterns, to be moved by beauty. These capacities would be extraordinary achievements for any programmer to create. Artists have long recognized this truth. Throughout history, artistic movements have emphasized that perception matters more than physical reality. Impressionist painters captured the experience of perceiving a moment of beauty rather than objective reality. Modern abstract art often focuses entirely on evoking emotional responses through pattern, color, and form. These artistic approaches acknowledge implicitly what simulation theory suggests explicitly, that subjective experience holds more inherent value than objective reality. Scientists, too, find wonder in mathematical patterns regardless of their origin. Richard Feynman remarked on the beauty he found in equations, stating that scientific discovery revealed patterns of such elegance that they inspired awe similar to appreciating great art. Understanding how a rainbow forms through refraction adds another layer of appreciation to its beauty. When we recognize that the value of our experiences lies in consciousness rather than material origin, many philosophical problems dissolve. The question isn't whether reality is real in some absolute sense, but whether our experiences have meaning. And meaning arises from consciousness, not materiality. The love you feel for another person doesn't become less meaningful if you're both simulated beings. The wonder you experience witnessing a perfect snowflake doesn't diminish if its mathematical symmetry comes from programming rather than physical laws. This perspective offers a profound resolution to the existential crisis that might follow accepting our status as experimental subjects. By locating value in consciousness rather than material reality, we find that nothing essential has been lost. The beauty we experience remains beautiful, relationships remain meaningful, and moral choices remain significant, perhaps even more so if they're being observed and evaluated by our simulators. Beyond the experiment, transcending the lab.